So, good evening, everyone. Welcome back to the NPTEL online certification course on water and wastewater treatment. And currently, we are in week 5. So, as you all know, the course instructor for this course is Dr. Bhanu Prakash from IIT Roorkee, and I am Akash Saha, one of the teaching assistant for this course. I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing environmental engineering in my PhD. Okay. So coming to the contents of this week 5 lecture, so we have extensively discussed upon the F by M ratio. Okay, so what is the relevance of this F by M ratio and what are the design parameters that are affected in the activated sludge processes. Then we looked into the problem of sludge bulking and what are the variations in the activated sludge processes are there. Okay, so what are the various types of formation of sludge bulking and all? So we have seen into that aspect. Then we started about discussing the sequencing batch reactor or the SBR. What are the various components and the processes relating to the SBR? And then we moved on to the nitrogen and phosphorus removal. Okay, so what are the various forms of nutrients, their removal mechanisms, etc. So this was the brief overview of this week's lecture. So I have some multiple choice questions followed by some theoretical type, or not theoretical, some subjective type questions. So we will solve them one by one, right? Okay, so this is the first question. It says that select the correct options regarding theta, that is HRT, and theta C, that is the SRT in the ASP. So HRT means the hydraulic retention time and SRT is the sludge retention time. So the option says if there is no sludge recycling in the ASP, then theta is equal to theta C. Theta C represents how much time the wastewater spends in the system. If there is sludge recycling in ASP, then theta will be greater than theta C. And at last, theta C represents how much time microbes spend in the system. So these are your 4 options. You have to tell me which of them are correct. Here we are comparing the hydraulic retention time with the sludge retention time. So please let me know whatever you feel are the correct options for this question. Okay, A and D. Okay, oh, you are also answering it as A, B and D. So just make a note that if B is correct, then D should not be correct. Okay, because one is hydraulic retention time, one is the sludge retention time. So either of them can be correct. So basically, if we see the answer for this, both A and D are correct because when we are talking about SRT, it is the time how much the sludge or the biomass or the microbes uh, are present in the system. Okay, and we want the sludge or the solids, the microbes to be for longer duration of time. That's why we do the recycling. Okay, if we don't do the recycling, then it would be acting as same as the HRT. So whatever hydraulic retention time you are giving for the system, it will be same as the solids or the sludge retention time. Okay, so that's why option A and D are correct. So in our system, in our ASP, we want more retention time for our biomass. So that's why we keep on recirculating them. Okay, so this is the answer for the first problem. We'll move forward. High F by M ratio is the best favorable condition for flocculation in the ASP. Is it true or false? So we are talking about the F by M ratio. So if I want that in my ASP flocculation should happen, so whether I should favor more F by M ratio or high F by M ratio or low F by M ratio. So what should I prefer? Just think about it for a minute. False. Any reason? Can you give any reason? Just type it in the chat box in a few words. So yes, your answer is correct, but what should be the reason? Can you tell? You can unmute yourself also and tell me, or else you can write it in the chat box. Okay, slime layer thickness at the start of endogenous. Okay, but how is it related to the flocculation? Okay, so answer is correct that it is false, and the reason being, if there is low F by M ratio, okay, it means that less food is available, okay, to the microbial population, and yeah, that is correct. That is correct. So it will make the bacteria to clump together, okay, to flocculate, and then efficiently consume whatever the limited source is present in the system. Okay, so due to the lesser availability of the food, the flocculation or the clumping of the bacterial mass will happen, and this will result in a denser and a more better settling flocks. Okay, so that is the reason. So we always try to provide low F by M ratio just in the case if we want a better settling of these flocks. Okay, so this is uh, kind of stress system given to the bacteria, so they try to clump together and form flocks. So actually today most of the question will revolve around this F by M ratio because that was the major part of discussion. So again and again the same concepts will come, so you can answer accordingly. Okay, the third question: dash acts as electron donor in the denitrification process. So which of them acts as an electron donor in the denitrification process? Is it nitrate, organic carbon, organic nitrogen, or nitrite? Any guess? So in any process, there is a electron donor and then there is a electron acceptor. Okay, so that has to be taken into consideration. So in denitrification process, what can be my electron donor? So wastewater, whatever you are saying is largely correct, but you have to be a little more specific. So what in wastewater? So it's basically the organic carbon. Okay, it's basically the organic carbon because this organic carbon will act as an electron donor in the denitrification process. Okay. So can someone tell me in what kind of system, whether it's an aerobic, anaerobic, or anoxic system for the denitrification to happen? What kind of system will you is preferred? Is it the aerobic system, anaerobic system, or the anoxic system? Anoxic system. So in anoxic system, if electron donor is organic carbon, what would be my electron acceptor? What would be my electron acceptor? Because anoxic system now oxygen is not there. So as I told you, in every system there will be an electron donor and an electron acceptor. So we discussed that in denitrification, electron donor is my organic carbon. Now denitrification happens in an anoxic system. So what will be my electron acceptor? Okay, so can someone tell me what is happening in a denitrification process? What is the form of nitrogen being converted to what form? Any idea? What is happening in denitrification? So here largely the nitrate is being converted to the nitrogen gas. Okay. So now tell me what is the electron acceptor? So nitrate is being converted to nitrogen gas. So what is my electron acceptor? Nitrate, not nitrate, it would be nitrate. Okay. So nitrate, so in any anoxic systems, oxygen is not the electron acceptor. So always remember either nitrate or sulfate. These kind of things will be my electron acceptor. Okay. Moving forward, activated sludge is the removable sludge from aeration tank. Sludge in secondary clarifier rich in microbial mass. Sludge in secondary clarifier rich in nutrients. All of the above. So what do we define as an activated sludge? This is very direct. Okay, you want me to explain about anoxic aerobic anaerobic process? So I was just telling you that there are three kinds of system. Those are aerobic, anaerobic, and anoxic systems. So in any system, there is an electron acceptor and then there is an electron donor. Okay, so in most of the systems, the organic matter or the organic carbon acts as the electron donor, whereas in any aerobic system, we have the oxygen. So it accepts the electron, so it acts as an electron acceptor. Okay, whereas in any anoxic systems, there is no oxygen present. So there the nitrate or sulfate acts as an electron acceptor. So that's what I was telling. And as far as this question is concerned, uh, okay, you are answering at B and C. Actually, only one answer is correct. So I know you people may be getting confused whether the sludge is rich in microbial mass or is it rich in nutrients. So mostly if proper denitrification or biological phosphorus removal processes are being done along with the aeration, then the nutrients will be very lesser. Okay, so most of the time the sludge in the secondary clarifier will be rich in only the microbial mass. So only B will be the correct answer. Okay, because we expect that this kind of in aeration tank, the ammonia is getting oxidized to nitrite, then to nitrate, and then with an anoxic system, we are also removing it. Maybe some selector zones are also provided in the system. Okay, so when it goes ultimately to the secondary clarifier, it would be mostly rich in the microbial mass and not in the nutrients. Whereas if we talk about any sludge from anaerobic treatment, these are all aerobic treatment. The activated sludge process, SBR, and all are aerobic treatment. Okay, so these are basically rich in biomass. Whereas if there is a sludge which is coming out from an anaerobic treatment, there would be no nutrient removal. Okay, so that sludge will be very much richer in nutrients as well as microbial mass. Okay, so you have to take care of that aspect. So since we are talking about activated sludge, it will be rich in microbial mass. When we are talking about anaerobic sludge, it will be rich in microbial mass as well as nutrients. Both the things will be there because there is no nutrient removal in the system. Am I making it clear? Is it fine? Okay, since only two of you are there, so I expect a reply. I hope you are listening to me. Okay, okay, thank you. That's or just you can put a thumbs up. That's all, so that I will know that you are able to listen and it's clear to all of you. Just put a thumbs up. Okay. Okay. Next. Thank you, Mohan. Thank you. So next question: what is the cause of bulking of sludge? Is it the absence of microorganisms, good settling microorganisms, poor settling microorganisms, or good mixture of floc and some filamentous bacteria? So when do we say that bulking of sludge is happening? So obviously, if it is a poor settling microorganism, then the sludge bulking will happen. Okay, so option C is correct. Direct question. Due to poor settling microorganism, the sludge bulking will happen. Now, next question. It is a bit conceptual. So you have to tell me there are two different ASP systems, okay, in the picture. In which system addition of methanol or acetone is needed as carbon source for effective removal of nitrates? So again, we are talking about the removal of nitrates, that is nothing but denitrification. So where do we need to provide additional methanol or acetone in the system as a carbon source? So is it system 1 or 2 or in both the system or not required in any of the systems? Okay. So just see the schematic, just think about it and let me know which one will be the correct answer. So in the first system, as you can see, so in both the systems, everything is same. Only the placement of aeration tank and the anoxic tank is different. So in the first one, the anoxic tank is before the aeration tank. In the second one, the anoxic tank is after the aeration tank. So what do you think will be the major challenge of keeping the anoxic tank before or after the aeration? So by that logic, you will be able to answer the system. So if we go back to the previous question, so I told you for any uh, system there must be an electron acceptor and an electron donor. So most of the time, as I told you, that organic carbon is my electron donor. Okay, so we need an electron donor in the system. And for denitrification, it generally happens in the anoxic region, right? The denitrification will happen only in the anoxic region, and in the anoxic region I want some carbon source. So either I have to additionally provide it, or it would be there with my wastewater there itself. So as you told me before that we need wastewater, that is nothing but a carbon source. So either the wastewater itself will have the carbon source, or I have to additionally provide the carbon source in the anoxic system. Now you try to answer. Am I able to make it clear? Now you think. So what will happen if I do aeration later or if I do aeration before? So now you will be able to solve it. Now think about it. Am I able to make it clear? Is the understanding clear in both the systems? Okay. Still, the concept I think is not clear. Okay, so tell me, suppose the wastewater is going directly to aeration. What will happen? What will happen to the organic carbon if I am aerating it in the presence of microorganisms? What will happen? Whether my organic carbon will remain in excess quantity or not, or it will be used up. So in the system 2, you can see that the BOD or the organic carbon in the wastewater is directly going into aeration. Okay. So while we are doing aeration, all this BOD, COD, whatever is there, all the organic carbon will get mineralized into CO2 and H2O or taken up by the microorganisms. So next, when it goes to the anoxic chamber, okay, there will be very less or no carbon present in my wastewaters. Okay, and we know that anoxic system needs some carbon, right? The anoxic system needs some carbon source. So during that time, we have to provide an additional carbon source. Okay, whereas if you see system 1, in the anoxic zone, already the wastewater is coming. So the carbon is already there in the system, right? For the denitrification to happen, for the organic carbon to act as an electron donor, the carbon is already present in the wastewater. So in this case, for denitrification, we don't have to additionally put any carbon source. Is it clear? So that's why only in system 2 we have to provide the additional carbon. Is it clear? Please tell me. Yeah, uh, that is true. And also one more thing is that here the internal recycling is not mentioned. Okay, so if we are using it as a system 1, okay, there should be some internal recycling from the aeration tank to the anoxic tank. Then the process will be much better, okay, much more efficient. Then the denitrification will happen much more efficiently. So that thing is missing here. But anyway, just to clear the concept, if the anoxic is after my aeration tank, then there is high probability that when my wastewater flows into the anoxic zone, there would be little or no organic carbon. So, and in that period, we have to provide the additional carbon source, whether in the form of methanol or acetone or whatever. Okay, I hope it is clear, right? We'll move forward. Okay, now a small numerical. So it says that the following data pertains to the ASP process as shown in the figure below. The F/M ratio is 0.25 per day. The mean cell residence time or the sludge age or the SRT as 12 days. Then calculate the volume of solid wasted per day. Okay, so we have to calculate what is the volume of solids that is wasted per day. The schematic is also given. So just try to answer, take a minute or two, and then tell me what is the correct answer. Okay, I'll wait for a minute or two. You try to solve it, then we'll discuss.
सर प्लीज एक बार क्वेश्चन को और से थोड़ा क्लेरिफाई कर दीजिए व्हाट इज सेइंग दैट क्वेश्चन मीनिंग
In this question,
यस यस
okay. Okay, I will. So in the question, it is saying that suppose this is question number 7. Okay, some wastewater is coming with a flow rate of 10,000 meter cube per day, and the BOD of that wastewater is around 150 milligram per liter. It is going into the aeration tank, right? It is the aeration tank where the MLSS is around 3000. That is the biomass concentration. Then it goes to the secondary sedimentation tank, okay, where the sludge will be formed. And here the MLSS is around 10,000 milligram per liter. And the effluent BOD that is coming out is around 20 milligram per liter. Now, some part of this will be coming out as waste activated sludge, and some of it is recycled back. So this is return activated sludge. Okay. So now they are asking what is the amount or the volume of solids that is wasted from the secondary sedimentation tank per day. So the volume of that they are asking. Okay. And some parameters they have given, that F by M ratio is 0.25 per day. The theta C or the SRT is 12 days, with the other parameters are there. So from this secondary sedimentation tank, some part of sludge is wasted per day. So what is the volume of that? They are asking. So you have to make use of this F by M ratio. Okay, you have to make use of this F by M ratio, then relate that to the SRT. Okay, try to solve this, or else I'll solve after a minute. Is anyone trying, or you are waiting me to solve it? If you are trying, then I'll wait for more time, or else I'll solve. Shall I go on? I think no one is trying this. It seems okay. Okay, so first let us see what is given to our in our question. So I know the F by M ratio, right? F by M ratio is given. So what is F by M ratio? F by M ratio is nothing but Q into the initial substrate divided by V into X. Okay, so V into X. This is for my system. So I can say F by M ratio is nothing but 0.25. My Q given is 10,000. Okay, the Q given is 10,000. Initial BOD, SI, initial BOD is 150. Okay, so initial BOD is 150 divided by volume. Volume of the tank I don't know. Where volume of the aeration tank I don't know, so it will be V into X. So what is the X in the aeration tank? It is 3000. So X is 3000. So here, from here I can calculate the volume of my aeration tank. So 2000 meter cube is the volume of my aeration tank. So this is the first data that we got. Okay, now next, now what else we know? We know the theta c. So theta c. So what is theta c? Theta c is defined as mass of MLSS or the biomass in aeration tank divided by mass of solids leaving the system per day. So if you see, we are asked the volume of the solids that is wasted. So if we know the mass, we can calculate the volume, right? So we will find out the mass. So suppose this mass of solid is some x, not x, because x and x again same thing is happening. So suppose this mass of this is something a. Let us call it as a. So what is theta c? Theta c is nothing but 12. Okay, mass of MLSS in the aeration tank. So mass of MLSS in the aeration tank is nothing but V into X. V into X, that is the total mass. Okay, and what is the mass of solids leaving? Is it is given as A. We are taking it as A. So it will give us 12 is equal to, now we know, we just found out as 2000, and what is X in the system? It is 3000 by A. So my A will come out to be 500 kg per day. So this will be my A. So the mass of solids leaving the system per day is equal to 500 kg per day. Now we just have to find out the volume, because in the question it is asking volume that is being leaving the system or wasted per day. So volume of solids wasted per day will be equal to the mass of solid wasted per day. This is nothing but this, the same thing, divided by MLSS in the underflow, sludge. So underflow sludge MLSS means the MLSS in the in this secondary clarifier. So that is nothing but the underflow sludge MLSS. Okay. So what it would be? It would be 500, right? 500 kg per day divided by it would be 10,000 milligram per liter. So if you change the units and cancel out the things, you will get it as 50 meter cube per day. So this is the answer. So volume of solid wasted per day is nothing but 50 meter cube per day. Is it clear? Any doubt in this? You can have one more look. So first we use the F by M ratio. Okay. So we know F by M ratio is QS by Vx. So from that we calculate the volume of the aeration tank. Next we related this to the sludge retention tank. That is nothing but the mass of biomass or mass of MLSS in the aeration tanks. That is nothing but V into X. And what is the mass of solids that is leaving the system per day. Okay, so I called it as A. So from that I found that A is equal to 500 kg per day. Now once we know the mass, we just have to divide by the MLSS to get the volume. So anything mass divided by density is just volume. So here the same thing, mass divided by the MLSS, which is in terms of the density. Is it clear? Any doubt in this? Right? We'll move ahead. Okay, so 50 meter cube per day is the correct answer. So the same thing, just written here. Okay, now next question says that calculate the volumetric loading rate in terms of kg per day per meter cube by using the question number 7. So for the same question, you have to find out volumetric loading rate. So can someone tell me what is the formula of volumetric loading rate? So the units are also given kg per day per meter cube. From this also you can uh, derive the formula. So what is the formula of volumetric loading rate? Any idea about it?
Q S not upon volume.
Yeah, that is correct. QS not by volume. So simply, so we will just put it the values. Okay, so volumetric loading rate is Q S naught or SI by volume. So Q is 10,000 into SI is 150 by 2000. So it is 0.75 kg BOD per day per meter cube. Very direct, very direct. There is no challenges there to find the answer. So same thing, right? Next question. I think this is the very one of the easiest question. So you have to find out what is my BOD removal efficiency in percentage in question 7. So you have to find out the BOD removal efficiency. So I will just open up the figure again. So seeing that, you please tell me what is the BOD removal efficiency. I think I should not solve this question because this is very easy. So please tell me what is the answer. Very direct. What is my BOD removal efficiency? I want all of you to please solve this. So for this question, I am asking what is my BOD removal efficiency? Okay, the whole schematic is given. All the values are also given. You have to just find out.
86.66.
Yes, that is the correct answer. 86.66667. So that will be the answer. So very direct. If we see the answer 86.67, how we are getting? So the initial BOD was 150. The final BOD coming out from the secondary clarifier is 20. So 150 minus 20 by 150 into 100. So it will be 86.67%. Right? I think it's nothing much difficult. Okay, we'll move forward now. Okay. Select the correct sequence of the characteristic growth phases of a pure culture of microbes. So we have different phases of growth for any microbe. So you have to tell me which one is the correct sequence. So please look into it. I think it's no point of reading out all the options. So just see the options and tell me which one will be the correct. So we have a stationary phase, we have an endogenous phase, we have a log growth phase. Okay, what else we have? We have a declining growth phase, we have an exponential growth phase. So all phases are there. So just in sequence, one after the other, you have to tell me the correct sequence of the growth phases.
Sir, is it option A?
Option A, okay. Yes, yeah. Yeah, I think most probably it is option A because first, if you see the curve, I have the curve, I think. Yeah. So first, actually, there is a lag phase. Okay. So here it is not mentioned. It is directly starting with the exponential growth phase. So first, there will be definitely a lag phase. So in that phase, the bacteria try to acclimatize with the surroundings, okay, or whatever environmental conditions that are being provided in the system. So the bacteria try to acclimatize. So in that time, very less or no growth, not much growth will be seen. So it is not exactly a flat line. There will be a little increase in growth, but not in that exponential range. Okay, so once it overcomes the lag phase, once it gets acclimatized, then the exponential growth happens. Okay, then the it will go exponentially, right? We have seen some formulas also related to this exponential growth phase, and then it starts to again decline. Okay, so once it starts to decline, the stationary phase will come. So at that time, the birth and the death rate is approximately the same. So that's why the stationary phase happens. Okay, and at last the endogenous phase happens. So endogenous, the death rate is much more and it feeded onto itself. The endogenous phase will start. It will feed on to its own protoplasm. It get oxidized. Okay, so that is the final endogenous phase, right?
Excuse me, sir.
Yeah,
एंडोजेनियस रेस्पिरेशन प्राइस पे हमको डाउट है सर, इसके लिए थोड़ा क्लियर कर दीजिए.
हाँ बोलिए.
इंडोजेनियस रेस्पिरेशन रेस्पिरेशन.
Yeah, so in endogenous phase, what happens since now till the time we reach the endogenous phase, most of the food or all of the food has been utilized. Okay, there is no additional substrate now. So either the bacteria will feed onto itself or some other bacteria. Okay, so that time the death rate will be more than my growth rate. So that's why the decline starts coming. Okay, in the stationary phase, it's almost the death and the growth rate is almost approximately the same. So it becomes stationary. And after that, the death phase or the decline phase or the endogenous phase happens. And as you are talking about endogenous respiration, it is nothing but feeding, like the cell's own protoplasm get oxidized. Okay, so that is the endogenous respiration there, which we discussed about in the last class. If you see, if you go back to the previous class, we have a similar question where we discussed about it. Okay. Okay. Now, in the previous question, in the endogenous phase, there is a little growth in the microbial population due to scarcity of substrate. Is it true or false?
True.
True. So definitely it is true. Just now we discussed, so it will be true. The endogenous phase is where low soluble BOD results in loss in viable bacterial cells and most importantly, lysis of the dead cells. So that's what happens. Okay, next question. Arrange the following into a typical process flow chart for an SBR. So we have pumping, decanting, sedimentation, aeration, and disinfection. So you have to tell me which one of them is the correct sequence of these processes in a sequencing batch reactor.
Option B, sir.
Option B. Anyone else? Any other opinion? It's a pretty direct question, so I don't think any other opinion will be there. So the option B is the correct answer, because first it will do the pumping, okay, the pumping of the wastewater into the system. Then the aeration will happen. So in this aeration, basically the organic matter is getting degraded, okay, and the formation of biomass is also happening. And then it will start getting settled. It will start settling, okay, the sedimentation will start. And once enough sedimentation is done, okay, the clear effluent will be decanted. It will be decanted and then it will be taken for disinfection.
एक्सक्यूज मी सर।
Yeah.
सर डिकैंटिंग में वो स्लज वाटर में सेटल हो जाता है, उसके बाद फ्रेश वाटर को बाहर कैसे करते?
So no, so see, the sludge will settle at the bottom, okay,
ओके।
and the clear water will coming on the top, will be coming on the top, okay, and
यस।
there will be some overflow weirs, okay, around the this uh, that chamber, that sequencing batch reactor chamber. So from that, the clear water will be coming out.
ओके। आई
Okay.
थिंक
Yeah.
एक्चुअली आई हैव नॉट अबाउट प्रैक्टिकल नॉलेज दिस सो कंफ्यूजन।
So you can see any, like you can see some images of this SBR. You will get to know. It's nothing but that the in the top the clear water gets separated, and then with the overflow weirs or whatever, it will be taken out. Okay.
सर अपना इस सर्टिफिकेशन कोर्स में मैं सजेशन में डाल रखा हूँ, हम लोग को लास्ट में कोई एक साइट पे विजिट कराने को, मतलब विजिट करने को मिलता तो अच्छा रहता, थोड़ा प्रैक्टिकल नॉलेज अच्छा हो जाता।
Yeah, that is true. Obviously, the practical knowledge will be much better. But the problem is, since it's an online course, okay, so people from all over the country or even from outside India are also participating in the course, right? So it will be
ओके।
very difficult to bring everyone together. What is the logistics? What is the financial
नो
problem?
नो नो सर, इसके इसके लिए एक सिंपल सॉल्यूशन है सर।
हाँ,
जो जो भी कैंडिडेट जहाँ से भी उसको कंप्लीट कर रहा है, उसका नियरेस्ट में 50 किलोमीटर 100 किलोमीटर के रेंज में जो भी अगर ऐसा कुछ प्लांट है, वेस्ट वाटर ट्रीटमेंट प्लांट है, तो वहाँ पे हमको एक परमिशन मिल जाए, मतलब लाइक एडमिट कार्ड मिल जाए,
but
तो
then
वो हम
all
लेके
this,
जाके हम परमिशन, क्योंकि विदाउट
yeah.
परमिशन
now
ऑथेंटिकेशन
now the
अंदर आने नहीं
problem
देंगे
is
वो।
there will be thousands of students, right? There will be thousands of students, so there will be thousands of wastewater treatment plant which will
यस
be governed by some governmental agencies, private agencies.
एंड प्राइवेट। यस
Yeah,
यस।
so a lot of logistic issues will be there. Okay, so though the
अगर नो
though
नो
the
अगर सर
approach is correct, I know your
कुछ
mindset behind it.
स्टूडेंट्स, अगर सबके लिए नहीं, अगर इसको मैंडेटरी करने का जरूरत नहीं है, ओनली इसको ऑप्शनल में रखिए। अगर कोई
Yeah,
कैंडिडेट चाहता है कि मैं किसी साइट पे जाके विजिट करूं,
yeah,
ओनली एक परमिशन मिल जाए, लेटर मिल जाए, परमिशन लेटर मिल जाए मेरे नाम के साथ, और उस साइट पे जाने का,
yeah,
फिर उस
I
लेटर में दिखा
I
के उस प्लांट में
understand
जाके विजिट कर
I
सकता हूँ।
understand your point one.
यस
Your
यस।
that mindset is correct. Whatever you're thinking is correct, but to be honest, it's not very feasible in as per my view. As per my view,
नो
it's
सर, इस
not.
चीज को इम्प्लीमेंट करने के लिए बोलिए सर, क्योंकि मुझे पूरा नीड है सर, मेरे को बहुत ज्यादा जरूरत है सर, क्योंकि मैं अभी हैदराबाद में हूँ, नियरेस्ट में हूँ, बहुत सारा प्लांट है, बट कोई भी मेरे को परमिशन नहीं देगा प्लांट में घुसने के लिए।
Uh,
अब मेरे प्लांट में ओनली ट्रीटमेंट प्लांट
no,
है, वेस्ट वाटर ट्रीटमेंट प्लांट नहीं
see,
है।
to be honest, I don't know what's the way forward here because it's an online course. So I don't know who
ओके।
will take this
कुछ
authority to give you this letter, but presently it will not be feasible.
ओके सर, इस फीडबैक को आगे फॉरवर्ड करिए अपने साइड से, तो शायद इस पे आगे चल के इम्प्लीमेंट
Okay,
किया
we
जाए।
will. You have put it in the forum, right? So let's see how they react to it.
थैंक यू सर।
Okay. Okay, we'll move forward. Sorry for the little distraction. Okay, the next question says that sludge bulking can usually be controlled by, and there are correct. There are four options: adjusting the F by M ratio, adjusting the temperature, the aeration, or the denitrification. So it's a very direct question. We have discussed much about it. So what do you think?
Option A, sir.
Option A. Can you tell a reason, like how we can adjust the F by M ratio? Should I increase it or decrease it? Any idea? so that my sludge bulking will reduce? What do you think? You can write in the chat box. No need to speak, or you can speak out also. That's up to you. So what do you think? So if I want to reduce sludge bulking, okay, should I increase the F/m ratio or should I decrease the F/m ratio? What should I do?
F by M ratio in the range of, I guess, like moderate ranges would not
No, I am just
cause.
saying in terms of relative terms, you can tell me like, should I prefer low F/m ratio or high F/m ratio? That's what is in question. Just think about it.
Maybe little lower, sir.
Yeah, little lower. That is true. So actually, you were not there in the first question, so that's why I wanted to discuss this
Yes,
again.
yes, sir. I
Yeah,
was a bit late. I'm sorry.
yeah. So the thing is, when we have a low F/m ratio, that means the availability of food to the microorganisms is lesser, right? Than the high F/m ratio. So what happens? These microbes will now struggle and now try to come together, clump together to get the food. Okay, to get the food, and in the process of clumping together or coming out together, they will form these flocks and try to settle. Okay, and once the settling properties are getting better, the sludge bulking will reduce. So that's why we say that low F/m ratio is generally preferable to reduce the sludge bulking. Am I
Yes,
clear?
sir. Understood.
Yeah. Okay. So since I think two of you joined a little late when we were discussing the first problem, so it was a similar question. So I just wanted to. Okay, high concentration of long chain fatty acids at low temperature, the excessive growth of. Yeah, there are chances that if some these long chain compounds are there, okay, so many a times the microbes or can get stuck to it, and temperature also will help to decrease the viscosity and increase the kinetic energy. So that is also true, but that is not the usual way we try to control the sludge bulking. Okay, it may give some impact as far as my view is concerned. I think, yeah, it may reduce the viscosity and give some better settling conditions, but for but it won't affect that much as your adjusting the F/m ratio will do. Okay, so I think in relative terms, adjusting the F/m ratio will do a lot more than adjusting the temperature. So that's why option A should be the correct answer. Okay, is it clear? Right. Again, the next problem, it says that select the characteristics of biological system with high F/m ratio. Excess food to microbes. Microbes have low energy to swim around. Good settling flocks formation. Fast microbial growth.
Option A. Option A, sir.
Option A, and there are actually multiple correct options. So what else?
B
Any other
also.
option?
B also. Option
B.
B.
B. See, if you are giving more food, will they have low energy? Okay, not really.
Maybe.
Not really. So the
Okay.
correct answer, as we just discussed, okay. So if you are giving high F/m ratio, more food, so excess growth and fast microbial growth will be there. Okay, so the growth rate will increase because of the excess food. So they will have more energy, not less energy. They will have more energy to swim.
Yes, sir. Okay. Sorry.
Yeah. And obviously, again, the high F/m ratio means the settling characteristics will not be that good. It will not be, it will kind of poor settling characteristics. So that's why option C is not correct. Okay. Okay, again, similar based question. What are the potential consequences of sludge bulking in wastewater treatment plant? Reduced treatment efficiency and increased effluent solids, increased energy consumption and operational cost, obstruction of pipes and equipments in the treatment process, all of the above.
All of them, sir.
All of the above. This is very straightforward because if sludge bulking is there, the settling will be lesser, so more solids will come out with the effluent. So my treatment efficiency gradually will decrease. Next, if more solids are coming out of the systems, then at a later point of time, again I have to treat them. If I am treating them again, so again the energy cost will increase, the operational cost will increase. And also, if more and more solids are coming, okay, and suppose there is a membrane reactor thereafter, or the pipes are there, so there are chances that those pipes and equipments will also get clogged or fouled. So that's why all A, B, C are correct options for this, right? So all of the above. What is the primary reason of bulking of sludge in wastewater treatment plants? Is it excessive growth of filamentous bacteria, inadequate mixing of wastewater and sludge, high organic load and low MLVSS in the aeration tank, insufficient aeration in the treatment process? So they are asking about the primary reason for bulking of sludge. Again, similar lines.
I guess option A again.
The option A. Any other option? What do you think is will be correct? Okay, so option A is definitely correct. But with that, if you see, option C is also correct. Why? Because it is saying high organic load and low MLVSS. So what is this? High organic load is nothing but high amount of food. Organic load is nothing but the substrate, that is the food. And low MLVSS. MLVSS is directly characterized with the microorganisms. So if high food and low microbes are there, that means my F by M ratio is again increasing. So if F by M ratio is again increasing, the bulking of sludge will happen. So that's why both option A and C are correct. Right?
Sir,
Yeah.
D may be option D not maybe correct.
Not necessarily. Not necessarily because insufficient aeration, maybe the treatment will not be enough. Okay, the amount, the treatment will not be enough, but I don't think it will be directly affecting your sludge, bulking of sludge. Whereas if you are asking about the primary reasons for the sludge bulking, option A and C are definitely, because they are asking primary specific reasons directly
Sir,
impacting the bulking.
मतलब I want to know what is the insufficient aeration. It means
Insufficient aeration by it means that whatever DO, the required amount of dissolved oxygen that has to be provided in your aeration tank, is not
yes.
provided. Okay, because there is a minimum level of DO that should be there for the organic matter to be degraded by the organisms, because the microorganisms will only act in the presence of dissolved oxygen, right? So there should be some sufficient amount of dissolved oxygen that should be present for the microbial degradation. So if it is not provided,
O-
that means some insufficient aeration is there.
Okay, sir. Okay.
Okay. And again, the same thing is coming into the picture. Like in any system, there is an electron donor, there is an electron acceptor. So in the aerobic systems, the oxygen is the electron acceptor. So if enough oxygen is not there, then who will be the electron acceptor? Okay, that the degradation will not be proper. Next question. Which of the following is not a variation of activated sludge process used for nutrient removal in wastewater treatment plants? Is it SBR, step aeration, extended aeration, or rotating biological contactor? Which of them is not a variation of activated sludge process for nutrient removal? So option D, definitely the rotating biological contractor. Okay, so there is nothing much to discuss in this. Okay, next question. Select the correct characteristics of nitrifiers. So we are talking about nitrifiers. Highly sensitive to DO, less detention time than heterotrophs, highly sensitive to toxins. DO can be used as a measure to control nitrification and denitrification.
Sir, please define what is meant by nitrifiers.
Nitrifiers are those organisms which helps in doing the nitrification. Okay, so like when there is some amount of ammonia is present in the system, it gets oxidized to nitrite, then to nitrate. Okay, with the help of some microorganism, microbial activity. So these organisms are called as nitrifiers. So we are talking about the characteristics of those nitrifiers.
Option A and option C, I think, sir.
Option A and option C, definitely, yeah. That is the correct option. And also option D. Because why? Because DO is a very important criteria for nitrification, right? Because oxygen is required to act as an electron acceptor, okay, in any aerobic system. So in nitrification, oxidation is happening from ammonia to nitrite to nitrate. Whereas in denitrification, it has to be done in an anoxic region. So there is no DO in that. So DO has to be controlled during the nitrification and denitrification. Okay, so option D is also correct, as well as option A and C. Because if you see in any system, first the heterotrophic bacteria will focus on removing the basic BOD COD. Okay, the nitrification will not start like in the early stages. It will take some time. It will take some time for these uh, microbes or the nitrifiers to function on the ammonia to oxidize it. Okay, so the detention time is more for these nitrifiers. So that is also one of another aspect in the case of nitrification and all, right? Okay, now a small numerical. So it says that determine the effluent BOD of the system. Okay, so all the parameters are given. The flow rate is given, the number of tanks, the influent BOD, what is the influent TSS, the first order death rate constant, the specific yield, and then the I think the specific growth rate, what is the half saturation constant, and the sludge. So all parameters are given. You have to calculate the effluent BOD. So it's a direct formula based question. If you know the formula, you will be able to solve it. So please apply the formula and let me know the correct answer. I will wait for a minute or two. And if you're not getting the answer, we'll discuss. Okay, I'll wait for a minute. Please go on. Any answer? Okay, we'll see how to solve this problem. So it's just direct formula application. I am not going into the derivation of it. Okay, so I'll just give you the formula and then we can solve it. So the formula is S, or the final effluent, is equal to the half saturation constant into 1 plus the depth decay rate into theta c divided by theta c mu m minus kd minus 1. So this is the formula. So if you know this formula, I think in the exam they can give all the parameters and miss one of them, and you have to find out either the half saturation constant or theta c or kd. Any one of them will be missing, or the s, and you have to find out the other terms, and you have to find out that term based on the information of other terms. Okay, so that's how it goes. So if you see this formula equation, so this is 115, then 1 plus 0.05 into 8 by 8 into 2.5 minus 0.05 minus 1. Okay, so S will come as 8.65 milligram per liter. Very direct. And I don't think you have to by heart any derivations and all. If you know the formula, that is more than enough. There are only few formulas which are important. In the last class also I discussed a few formulas, and here also again some formulas are there. So just you have to go through it. Okay, so this is the first question. Next,
सर
yeah,
इस फार्मूला में अगर सीता थीटा सी कैलकुलेट करना हो,
हाँ,
बाकी सब वैल्यूज दिया हुआ तो कैसे करेंगे?
yeah, you have to bring theta c to only one side. You have to like multiply and divide, okay, and bring the theta c to one side, simplify the formula, then put the rest of the values and solve. It can be done,
Okay,
right?
it's right, but unable to do that.
Yeah, it will be a
ऊपर
little
थीटा,
complex. It will,
नॉमिनेटर में भी थीटा सी है, डिनोमिनेटर में भी
yeah,
थीटा सी है.
I know sometimes it can become a little complex. So most of the
Yes.
time theta c will be given. Okay, as far as I have seen, most of the time it will be given. I don't.
ट्यूटोरियल्स में सर का ट्यूटोरियल्स में एक क्वेश्चन सॉल्व किए हैं सर,
Or
भानु
else,
सर,
or
वो
else, see, if
समझ नहीं पा रहा है.
no, if theta c is not given, in
यस.
many there are several other formulas. Okay, there is one more question where
यस.
they have done the material balance of the completely mixed aeration basin, and
यस.
we are finding theta c based on some other parameters.
हाँ, ऑलरेडी इधर सॉल्व मैं कर चुका हूँ थीटा सी कैलकुलेट करने के लिए, बस उधर दूसरा पैरामीटर था, बट इसमें ये सारा दिया हुआ है, बट इसमें से थीटा सी अगर माइनस सारे वेरिएबल्स के अकॉर्डिंग अगर फाइंड आउट करना हो तो फिर नहीं हो पा रहा है.
Mhm. Okay,
यस.
I think it's just nothing but we have to simplify only. But yeah, that is true. Sometimes it will get a little tricky when
यस.
both denominator, or else most of the time this will be MCQ. Here I am giving it as this numerical type, but it can be MCQ also. So you can check with the answer
ओके सर.
which one is fitting. Okay. Okay, so next question. It says that, so there are three questions back to back. So we will solve one by one. And all the questions are related to this data. So it says that consider a municipal wastewater treatment plant. It uses traditional activated sludge process. The population is 8,000 people. Waste generation per capita is 200 liter per day. Influent BOD is 220 milligram per liter. MLVSS, decay constant, yield, everything is given. Now assume that the PCB enforces a treated wastewater standard of BOD5 equal to 20 milligram per liter and suspended solids of 20 milligram per liter. So this is the data that is given for all the question. Okay, for the next three question, this is the data. So you can take a screenshot of this. Okay, just take a screenshot. We'll move ahead and see what are the different questions they're asking. It says that if the volume of the reactor is 325 meter cube, then the hydraulic retention time of the wastewater in the tank in hours to achieve the required quality of treated wastewater is.
Sir, please go back to the previous slide, sir. I didn't make a note.
Okay. So here they are asking that if the volume that is given is 325 meter cube, what will be my hydraulic retention time? PCB is nothing but pollution control board. So they are saying that PCB, the pollution control board, is saying that the final effluent should have a BOD 5 of BOD at fifth day as 20 milligram per liter and suspended solids at 20 milligram per liter. So what would be my hydraulic retention time if the volume is 325 meter cube? So very direct. Just tell me the answer. And mind you, you answer it is in hours. Okay. Okay. So just take care of the unit and answer in terms of hours. Any answer? This is very simple. Direct formula you can apply. And the formula itself is very simple. No need to memorize anything. So what is the HRT? How do we define HRT? Any idea?
Yes sir, वॉल्यूम अपॉन फ्लो मतलब वॉल्यूम
Yeah,
अपॉन फ्लो.
yeah, that's all. So just
वॉल्यूम
take a
पॉपुलेशन इनटू पर डे 80,000 into 200
yeah, that is true.
एंड वॉल्यूम हो गया हमारा, नहीं दिस इज फ्लो
325.
हो गया. वॉल्यूम कितना है?
325.
वॉल्यूम
Volume is 325. It's given in the question. Okay, so just divide it and tell me what is the answer. Just make note of the units. Okay, it should not be in days, it should be in hours.
30 माइनस हो जाएगा तो 3700 बटा 320. 11.25.
No, something is wrong. In hours. I think he left the chat. Let him join back. Yeah, Mohan, your answer was incorrect. You just see the units. So here you have to take care that the sewage generation is in liters. Okay. So you have to convert into meter cube and also then convert the days into hours.
सर 0.09 वो डिवाइडेशन गलत कर दिया।
हाँ,
2 point
0.09 it is days.
यस सर, यस सर 0.09 वो
What is in
मैं
hours? In hours?
2.2, sir.
Yeah, it is approximately 2.2. So the option given is 2.167. So you can go ahead with 2.167. Okay. So just V by Q. So V is 325 divided by 18,000. That is the population into 200 liters. So we will convert into meter cube. So divide by 1000, you will get 0.0903 days or 2.167 hours. Okay. Next question. The average time for which the biomass stays in the system. So you have to find out the average time. That is nothing but the SRT. Okay. So I'll go back to that question. So just see the information given below and find out the HRT. So here the problem what Mohan was just saying. So the formula will become little complex with the theta c. So maybe with hit and trial method or by simplifying it slowly, we can find the answer. Yeah, I think it can be done if you simplify it. If you simplify it and bring all the theta c terms to one side and then solve the rest of it.
सर थीटा सी फाइंड आउट करना है।
हाँ,
वो फार्मूला में वैल्यू पुट करना पड़ेगा। बी
yes.
इंटू एक्स डिवाइडेड बाई क्यू माइनस क्यू डब्ल्यू इंटू एक्स ई प्लस क्यू डब्ल्यू इंटू एक्स आर।
No, but that formula, but here we don't have the information regarding
हाँ
XCR
बट
and all.
इसमें हाँ ये फार्मूला अप्लाई नहीं होगा क्योंकि इसमें वैल्यू अलग है,
Yeah,
दूसरा
so
वैल्यू।
it is somewhat similar to the previous formula, but not really. We have one more formula for it. I will tell you. Okay, so let's discuss. I will tell you. So you can make note of this formula also. So when MLSS terms or MLVSS terms are given, you can use this formula. So
यही क्वेश्चन में बीच में पूछा था सर, अगर थीटा सी माइनस
yeah,
फाइंड आउट करना तो कैसे करेंगे?
yes. So the formula is like x is equal to y divided by 1 plus kd theta c, okay, into s naught minus s, again theta c will come by theta. Okay, so here theta is the hydraulic retention time which we just calculated, or which we, yeah, in the previous problem we just calculated the hydraulic retention time, so that will come. Okay, so here if you see, my x or the MLVSS value is 2800, y is 0.5, 1 plus 0.05 theta c into 220 minus 20 theta c divided by, here you can find the answer in days. So I will put HRT, what we got in days. Okay, so that's what I'm putting. And if you simplify and solve this, you will get theta c as 2.896 days.
सर इसको थोड़ा और सिंपलीफाई करके बताइए, थोड़ा और इजी वे में वैल्यू कैसे
See,
आया?
simplify means what? You will first take this 0.09 to this side, then take this term to this side, okay, and then multiply individually. You will get some number plus some constant with theta c this side, and here it will be 0.5 into 210 into theta c, right? Suppose this is A, this is B. So now you will get A is equal to 0.05 of 2210 will be 105 theta C minus B theta C. Okay, then A will become 105 minus B into theta C. So theta C will be 105 A divided by 105 minus B. Something like that it will come. It will be very simple. Is it clear? Yeah, I think there is not much problem. It's just that it will take some time to simplify. That's all. Right? So, yeah, that's what is given here. The same thing, same formula is given. So, just input the values and you will get the answer. Okay, the last problem for this batch of questions. It says that if microorganisms reach half of their maximum growth rate when BOD 5 concentration is 120 milligram per liter, what is the maximum growth rate? Okay, so just read the question carefully. It is saying if microorganisms reach half of their maximum growth rate when BOD 5 is 120 milligram per liter, then what is the maximum growth rate? So now tell me what parameter is given and what they are asking. There are two terms here. One term is given and one term is being asked.
Ks is given and mu max is asked.
Very good, exactly. So when the half half of maximum growth rate is reached, so that corresponding BOD concentration, we say it as half saturation constant. That is nothing but the Ks. So now we know that Ks value is 120 milligram per liter. And what is the maximum growth rate? Maximum growth rate is nothing but the mu max. Okay. So now we will go back to all the data that is given. Okay, so these are all the data is given, and you know the half saturation constant also, and you have to find the mu max. So what formula? I've already given you the formula with half saturation constant, mu max, KD, theta C, S. Okay, with everything. That formula is already given to you. So just put the values and tell me the correct answer for mu max. I hope you know which formula to apply, right? We just discussed a few questions before. So just input all the values and tell me the correct answer. Are you able to get it, or is anyone trying? I hope you are doing that.
I'm trying, sir. Give me a minute.
Yeah, yeah.
Sir, is the answer 0.02?
0.02. No, I'm not getting the same answer. Uh, let's see. The answer that is coming is 2.76. Okay, maybe you can recheck your calculation. Okay, but whatever be the case, this is the formula. Okay, the same formula we have to apply. So everything is known, and just you have to solve it and you'll get the answer. Okay, so okay, we'll move forward. I think we have few more MCQs. Facultative bacteria are able to work in presence of O2, absence of O2, presence as well as absence of O2, none of them.
Option C?
Option C, definitely that is the, because these are facultative bacteria which can survive or thrive in both absence and presence of O2, while there are strict anaerobes or strict aerobes. So they will be either uh, be present strictly in aerobic or anaerobic conditions. So that's how they are defined, whereas facultative can survive in both. Okay, next is a match the following type, where we have anoxic, heterotrophs, anaerobic, and autotrophs. So all the definitions are given on the right side. So you have to just match it. So please try to match it with their respective definitions or description.
Option B, sir.
Option B. So let's see. So anoxic condition means absence. Option B, you are saying B or D?
I said B. B, sir. A,
B.
B.
Uh, okay. Okay, right, yeah. So anoxic conditions means only the absence of oxygen. Okay, whereas in anaerobic, all the electron acceptors like nitrate, nitrite, oxygen, everything will be absent. Whereas heterotrophs are those which will obtain its energy and material from the organic sources, and autotrophs are those which will obtain its energy and materials from the inorganic sources. Okay, so option B is definitely correct. Again, the sludge working is coming, so I will just skipping it because same questions are coming. Uh, okay, yeah, this question is little better. So it says that select the correct statements regarding F by M ratio. If the cell residence time is kept same and we increase the F by M ratio, the efficiency of the process will increase. F by M ratio for endogenous phase is lesser than for exponential growth phase. In low F by M ratio, cells get starved and nearly all substrate gets consumed. In high F by M ratio, there is faster bacteria growth, which leads to a thicker slime layer. So which of the options are correct?
I think B and C, sir.
B and B and C. Okay. Uh, what else? Any other opinion? When someone is saying D. So the correct answer is only B and C. Okay, because in high FOM ratio, there won't be a thicker slime layer, there will be a somewhat thinner slime layer. The flocculation will not happen properly, and the slime layer will not be forming in a much better way. Okay, whereas in the endogenous phase, obviously the FOM ratio will be lesser because there is a less availability of food, and in low FOM ratio, the cells obviously will get starved and all the substrate will eventually get consumed. And also, if we increase the FOM ratio, the process efficiency will decrease. That's why option A is incorrect. Okay, so that's all. Next question. Select the correct statements regarding nitrogen removal process. So it says that 1 gram nitrogen requires 4.57 gram of O2. Nitrogen removal sequence is organic ammonia, then ammonia nitrogen, then nitrate, then nitrate to nitrogen gas. If oxygen is not present during denitrification, N2 gas will not be given out. Redfield ratio is C is to N is to P as 106 is to 26 is to 1. So which of the options are correct?
To my knowledge, option B and C, sir. I'm not sure about A and D.
Option B and C. So do you think that denitrification oxygen is required?
Sorry, sir, I read it wrong.
Yeah. So
Yeah.
that's why option C will not be correct. Whereas option 1 is definitely correct because per gram of nitrogen we need 4.75 because in the equation also it comes 4.757 times of oxygen. Okay, so option A is correct. Option B is also correct because from organic ammonia it will be changed to ammoniacal nitrogen, then after oxidation to nitrite, then immediately it is a spontaneous reaction, it will be changed to nitrate, and then by denitrification it will be changed to nitrogen gas. And whereas the Redfield ratio is actually 106 is to 16 is to 1, not 26, it is 16 is to 1. Okay, so option A and B are correct. Okay, again one big numerical is there, so it is just divided into parts, so for each part there is one formula. So I think it's all direct, so I will not discuss this. Okay, so I have given you the correct answers here, you can try it out and see if you're getting these correct answers, and in case you are not able to solve, you get back to me, you can drop me a mail, I will give you the solution. Okay, but for this class,
क्वेश्चन 27 को रिपीट करिए
sorry.
ओनली स्क्रीन क्वेश्चन 27 को थोड़ा बैक करिए स्क्रीनशॉट लेना
Okay, take this screenshot. Okay, yeah. So this question I am leaving up to you. You try to solve because these are only one-liner uh, questions. Okay, first like effluent BOD, then removal efficiency, concentration of microorganisms, all are one-liner. Okay, so formulas are there for each of them. You try to solve it and see if you are getting the correct answer. Right. The next question is important. Okay, please go through it slowly and try to understand, see what parameters are given and what is asked. So it says that in a biological treatment facility, it was found that 1 gram of microorganisms would decompose glucose at a maximum rate of 1.5 milligram per day when the concentration of glucose is high. It was also found that the reactor at glucose concentration of 15 milligram per liter, the reaction rate is half of the maximum rate. Okay. Calculate the rate of glucose decomposition, which is nothing but ds by dt, when glucose concentration remaining is 5 milligram per liter and microorganisms concentration is 2 milligram per liter. Okay. So a lot of information is given in this question. So just try to segregate the information. See what are the parameters that are given. So everything is given in the form of a sentence or story. Here it is not given that this is mu max, this is ks, this is s. Nothing is given in that sort. Okay, so everything is given in terms of a sentence. You first try to segregate what are the parameters that are being given and what is asked. Okay, the formula is very simple. Okay, for this question also I'm not telling you the formula. The formula is also very simple, but you should know what are the parameters. Okay, identify the parameters and you can tell me. Okay, maybe we can discuss the parameters now, but solving part you have to do it. Okay, so can anyone tell me any parameters what is being given? Any of the parameter?
Mu max
Okay, what is mu max here?
1.5 mg per day.
Mu max 1.5 mg per day. Okay, what else?
1
So
gram of microbes
actually
is
what you are saying is mu, whatever you are saying, it is not 1.5 mg per day. It should be 1.5 mg per milligram of VSS per day. So that's why that 1 gram of microorganisms has also be taken into consideration. Okay, if it is 2 grams, then 1.5 by 2 will come. Since it is 1 now, it is not affecting your parameter, but ideally it should be 1.5 by 1. Are you understanding my point?
but the values are in mg and grams.
That doesn't matter. It should be some mass per mass.
Okay.
Okay. Because if you see, what is the unit of my mu max? Is it milligram per day?
No, sir.
It is per day only, right? So
Yes, sir.
when we are defining it milligram per gram, so ultimately the mass terms are getting cancelled. So ultimately it is a per day term, right? What else is given? Any other idea?
Ks
Ks, what is Ks here?
15 mg per liter.
15 milliliter, because definitely half of maximum rate, that corresponding substrate is given. So Ks is also given. What else is given? So also S value is also given, the substrate value. Okay, so you have to find out for a substrate of 5 milligram per liter. So S is also given. Okay, so glucose is my substrate here, or the food to the microorganisms. So S is also given. And the final microorganism concentration is also given. That is my X. So X is also given. So in essence of it, we have the mu max or the mu value, we have the ks value, we have the s value, and we also have the x value. Now what we have to find out? We have to find out the ds by dt. Okay, so ds by dt is the rate of substrate utilization. So how much substrate is being utilized with time? Okay, so directly one formula is there. You try to solve this problem also. Maybe this is not directly related to uh, the type of questions which you are solving again and again, but it will clear your understanding. So that's why I've given this question. You think about it. Now you know the parameters. You try to solve. If you're getting with any answer, you just mail it to me. Okay, or else I will discuss it in the next class. I will make a note of it. I will discuss it in the next class before starting. Okay, so for now I am just stopping with this question, right? Uh, Okay, so also I'll give you the correct answer. The correct answer is ds by dt is minus 0.75. Okay, kg glucose per meter cube per day. Okay, you can make a note of it. you see if you solve the problem and see if you are getting the correct answer. Okay, so that's all from my side for today. So we will meet again on 4th March, same on Tuesday, 7 to 9 p.m. And if you have, like we have discussed some of the problems and I have left some problems to be solved by you. So if you are getting any answer or if you are stuck at some place, you can immediately mail me. I'll be happy to discuss with you over mail. And previous, sorry, I don't have access to the previous year final exam paper. I can only discuss the previous year assignment problems, which I am anyway doing with you. Okay, but final exam problem I don't have access to. So sorry.
Sir,
Yeah.
suppose I want to see the list of plants in regarding specific districts, wastewater treatment, like government or private.
Okay.
How can I see it? List of plants.
I think as far as I know, most of the state government pollution control board or the SPCB, okay, state pollution control board. So in their website you will find it. As far as my knowledge is
Okay, sir, I
concerned.
will
Okay,
try.
you check
Okay.
the particular state's pollution control board site. Suppose if West Bengal is there, West Bengal PCB, WP PCB, or Kerala or Maharashtra, you can search and you can see the data that has been published in those sites. Okay, you will get an idea. I think Central Pollution Control Board will also have that data, but I'm not sure if district wide it's there. Because overall picture they will also take care, because how many treatment plants are there, what kind of treatment plant, okay, what is their capacity, it's there with the pollution control board.
सर ये फाइनल क्वेश्चन फाइनल एग्जाम में ये असाइनमेंट से ही क्वेश्चन आएंगे क्या कैसा है?
Not really, not like it will be somewhat similar to the standard of the assignment problems. Okay, not exact ditto problems, but of the same standards. Yeah. So there will be some numerical type questions, and there will be some MCQ type of problems.
And scientific calculators are allowed, no, sir?
Yeah, I think the scientific calculator will be available in the portal itself, like how it is provided in the GATE exam. It will be provided in the portal itself. It will be anyway in your admit card. It will be clearly written whether you are allowed to bring scientific calculator or it is there in the portal. Because in most of these online examinations, uh, uh, like the GATE like the GATE examination, you are not allowed with a scientific calculator, but it's there in the portal. So don't. Thank you, Mohan.
Okay.
Thank you for your feedback.
Thank you, sir.
Okay, thank you, Jyoti.
थैंक यू सर
Okay, so that's all from my side. If don't have any doubts for now, you can leave the session. We will meet again next Tuesday. Okay.